Hello! Welcome on our channel, Science Scope! I am a student at a university studying astrophysics with a concentration in astronomy, and I welcome you to my channel. In this video, we are going to talk about observatory spacecrafts. An observatory spacecraft does not travel to a destination to explore it. Instead, it occupies an Earth orbit or a solar orbit from where it can observe distant targets free of the obscuring and blurring effects of Earth's atmosphere. There are many advantages to placing an observatory spacecraft into orbit rather than on the surface of a planet. First, it can continuously observe one hemisphere of the planet without having to deal with the complications of planetary night. Second, by placing the observatory spacecraft into a higher orbit, it is possible to avoid the obscuring effects of the planet's atmosphere. And third, the craft can be placed into an orbit which keeps it out of radio contact with the planet. This is important for radio astronomy because radio waves can be absorbed or scattered by the atmosphere or by satellites and spacecraft in lower orbits. The only drawback to placing an observatory spacecraft into orbit is that it cannot move around to face its target. Therefore, the telescope must be pointed accurately in order to track the target as it moves through the sky. This generally means that the target must be relatively bright, so that it can be easily tracked. NASA's Great Observatories program studies the universe at wavelengths from infrared to gamma. The program includes 4 observatory spacecraft: the familiar Hubble Space Telescope, the Chandra X-Ray Observatory, CXO, previously known as AXAF, the Compton Gamma Ray Observatory, and the Spitzer Space Telescope, previously known as SIRTF. As of early 2023, the HST is still operating. GRO has completed its mission and was deorbited in June 2000. CXO was launched in July 1999 and continues to operate. SIRTF launched in January 2003 and its mission ended January 30th, 2020. In the coming decades, many new kinds of observatory spacecraft will be deployed to take advantage of the tremendous gains available from operating in space. Our prime example of an observatory spacecraft is the Spitzer Space Infrared Telescope facility. We have already talked about this telescope in other videos, and if you want to know more details about this telescope, I recommend you check those videos out. Other examples of observatory spacecraft include Neuster Nuclear Spectroscopic Telescope Array, WISE Wide Field Infrared Survey Explorer, HST Hubble Space Telescope, Chandra X-Ray Observatory, Compton Gamma Ray Observatory, IRA's Infrared Astronomical Satellite, NGST Next Generation Space Telescope, SIM Space Interferometry Mission, Planck Cosmic Background Radiation Field Survey, and JWST James Webb Space Telescope. Let's go over some of these briefly. The Neuster Nuclear Spectroscopic Telescope Array is a small observatory spacecraft equipped with 2 X-ray telescopes that was launched in June 2012 to study high-energy phenomena such as supernova, black hole candidates, and active galaxies. WISE is a telescope that surveys the entire sky in infrared light to detect things like asteroids, comets, and other objects that orbit the Sun. It also studies newly forming stars and galaxies. The telescope was launched in December 2009 and completed its primary mission in February 2010. It then entered an indefinite mission extension called NEOIS, where it continued to make discoveries until its fuel ran out and it was decommissioned in March 2019. The HST Space Telescope is probably the most famous space telescope ever built. It was launched in April 1990 and has revolutionized our understanding of the universe. It was initially designed to observe in the visible and ultraviolet portions of the electromagnetic spectrum, but has since been modified to also observe in the near-infrared portion of the spectrum. The Chandra X-Ray Observatory is a large observatory spacecraft that studies X-ray sources such as supernova remnants, black hole candidates, and active galaxies. It was launched in July 1999 and continues to operate. The Compton Gamma Ray Observatory is a large observatory spacecraft that studies gamma ray sources such as gamma ray bursts, pulsars, and black hole candidates. It was launched in June 1991 and completed its mission in June 2000. The Spitzer Space Telescope is a space telescope that observes in the infrared portion of the electromagnetic spectrum. It was launched in August 2003 and has revolutionized our understanding of the universe. The telescope was originally named the Space Infrared Telescope Facility SIRTF, and was later renamed in honor of the third Vice President of the United States, Senator Charles Spitzer. The telescope was designed to observe in the warm infrared portion of the spectrum, but has since been modified to also observe in the cool infrared portion of the spectrum. The Spitzer Space Telescope has made many incredible discoveries, including the first detection of water on the surface of the Moon, the discovery of the first exoplanets using the transit method, and the discovery of the first interstellar organic molecules. The telescope is currently in its mission extension called the Spitzer Space Telescope Beyond 2020 and continues to make incredible discoveries. The IRIS-ORA infrared astronomical satellite was a telescope that observed in the infrared portion of the spectrum and was launched in January 1983. It made a complete survey of the skies in the northern hemisphere and discovered many infrared sources, including asteroids and objects in the Kuiper Belt. The satellite completed its mission in January 1988. The NGST, or Next Space Telescope, is a large space telescope that will observe in the infrared portion of the spectrum. It is currently under construction and is scheduled to launch in December 2021. The telescope is being built by Northrop Grumman for NASA and will replace the aging Hubble Space Telescope. The SIM, or Space Interferometry Mission, is a space interferometry mission that will measure the angular diameters of nearby stars. It was launched in August 2010 and is currently operational. The Planck Cosmic Background Radiation Field Survey is a space mission that mapped the cosmic microwave background radiation. It was launched in May 2009 and completed its mission in October 2013. The Planck satellite also made a number of other important discoveries, including the first detection of gravitational waves. The JWST, or James Webb Space Telescope, is a large space telescope that will observe in the infrared portion of the spectrum. It is currently under construction and is scheduled to launch in December 2021. The telescope is being built by Northrop Grumman for NASA and is designed to be the successor to the aging Hubble Space Telescope. So that wraps up our list of observatory spacecraft. As you can see, there are many different types of observatory spacecraft that serve different purposes. However, they all share one common goal: to make incredible discoveries about the universe. So the next time you look up at the night sky, remember that there are spacecraft orbiting our planet, making it possible for us to understand the universe in which we live. I hope you enjoyed this video, and I hope it has helped you learn something new. If you have any questions, feel free to leave them in the comments below, and I will do my best to answer them. Thanks for watching, and I'll see you next time.